We first observed a stream change color at a site that we were monitoring.
We were out there in 2017. Everything was great. We were collecting fish, collecting macroinvertebrates. And then we came back in 2018, and the whole river, whole small tributary had turned orange.
At first, when we saw this color change, we thought it was somewhat anomalous.
I couldn't find any fish in the stream. The macroinvertebrate community had been kind of decimated.
It was interesting, and that we should collect all the data we can to understand it.
Really startling to see. You're in this remote part of Alaska, no one's around, and these rivers are orange.
And then all of a sudden we realized like this phenomenon wasn't just this one-off from 2018.
Now we have over 70 observations of streams and rivers that have changed color.
And I'm very interested in understanding the consequences of this.
When it was first shown to me in photos, I was really surprised to see that. I used to teach a lab that focused on acid rock drainage and acid mine drainage in the Colorado Rockies, and so we would take students out to these abandoned mines. We're seeing the same sequences of changes in water chemistry in these rivers, but far from mine sources.
So our research group has identified over 75 impaired streams and rivers across the Brooks Range. The Arctic ecosystem as a whole, both aquatic environments and human health, are threatened by this change in water chemistry across the region.
Our working hypothesis is that the thawing of permafrost soil is allowing the water to infiltrate deeper and interact with minerals that have been locked away for thousands of years. And those minerals are weathering or undergoing a reaction with oxygen in the water. And then when that water then enters a river, the pH increases and a lot of the metals precipitate out. And the one that we see most visually is iron, which is why the rivers look like they're rusting.
So some toxic metals that we're seeing include zinc, copper, nickel, lead. Metals are toxic to fish, and so this can have a negative impact on aquatic ecosystem health. And then this also deteriorates water quality. That's important for local rural communities that rely on fresh water and subsistence fishing.
The fish in these watersheds are an important component of people's diets. They rely on this food resource for their livelihood. You know, it's a dinner plate issue.
I mean, one thing that is really striking to me, these inputs of metals are so large that we can see them from space. What we've observed so far is that from one year to the next, the systems are dynamic. It's changing. So in terms of how it's going to behave long term, we don't know that answer, but I am confident that there will be some places where it can improve.
I think our next steps are set up a study design so that we can really start to point to some of the mechanisms that are driving this and to start understanding what some of the consequences are going to be.
The Arctic is warming at a much faster rate. I think most recent estimates are that it's warming about 4 times the rate as the globe as a whole. If permafrost thaw is the primary mode allowing for this to happen, wherever there are places with this type of mineral deposit, there's going to be potential for this acid rock drainage to make its way into streams and rivers.
Our hope is to build an assessment of which rivers are most sensitive and where it's likely to happen. And with those 2 pieces of information, we can then assess what the impact could be to aquatic life.
There's a lot of scientific questions, so there's plenty of room for everybody to test their theories and think about things. So it's been a very, very positive collective work overall.
I think this is a unique project because most of the time when we're thinking about water quality and chemistry, we can't see the change. The change is so visible and it's so dramatic.
I feel an obligation to do the best science we can to try to assess what are the actual impacts. There's more unknowns than knowns at this point. And my hope is that I have the opportunity for several years to help target parts of those key questions about what are the impacts to aquatic organisms and what is the fate downstream and how might it impact larger processes across the Arctic.